Hello everyone and welcome to my YouTube channel. As I said, physics is a practical subject and we need to sharpen our skills when it comes to answering physics paper 3. So welcome, I hope you enjoy. If you are new, kindly subscribe. So physics paper 3. So there are basic things that we do or we measure in a practical subject when we are dealing with physics. For example, length, time, angle, temperature, current, voltage, diameters, volume, mass, and depth. So which these instruments that we use to make those measurements? So we use a meter rule to take length, a vernier caliper, micrometer screw gauge, ammeter to measure current, voltmeter to measure voltage, thermometer to measure temperature, protractor to measure angle, electric beam balance to measure mass. So how do we take these measurements? So when we are taking the measurement using a ruler, we should make sure that our eyes are perpendicular to the point we are making the measurement. For example, to take the measurement of this reading, it should be 38.6. Its accuracy is to 1 decimal place. So any measurement we take using a meter rule should be to 1 decimal place, not to 2, not to none, but to 1 decimal place. For example, this is 20. It should be presented in the analysis work as 20.0 centimeters. The next apparatus we use is a micrometer screw gauge. Its accuracy is to 2 decimal places, 0.01 millimeter. So therefore, like for this case, we'll read this as 2.88. 2 is on the main scale and 88 or 2.5 is on the main scale and 0.38 is on the thimble scale. So I'm sure we know how to use a micrometer screw gauge. So when we use a vernier calipers, its accuracy is to 2 decimal places. So any measurement we take using a vernier caliper should be presented to 2 decimal places. And we look at maybe later how to make readings from a vernier caliper. So we have the main scale where we have 4 to 5, and we have the vernier scale which runs from 0 to 10. So the reading we take from the main scale is, for example, in this case is 4.3. Then we add 5. So the fifth mark in the vernier scale is the one coinciding with the mark in the main scale. So 5 we multiply by 0.01 and then we add to 4.1. When we use a measuring cylinder, again, it should be to 1 decimal place. Ensure that your eye is parallel to the reading you are making. And again, we are supposed to make the reading using the lower meniscus. The lower meniscus means the lowest point where the level of the water curves. For instance, in this case, we are showing the lower meniscus, which is 20.70. So high accuracy is not penalized. So when you use a thermometer, the thermometer, its accuracy is to a whole number. So we talk of 20 degrees, 30 degrees, etc. A stopwatch should be read to 2 decimal places. So we can see 03281. That should be read as 32.81 seconds. And therefore, we should not include the colons that appear on the stopwatch. The next one is the ammeter. As we talked about the ammeter, its accuracy should be to 2 decimal places. We have the lower scale running from 0 to 3, and then the upper scale 0 to 1.0. So we connect the red knob and then we use that reading. For instance, that is 1.55 using the lower scale. Therefore, all readings using an ammeter should be taken to 2 decimal places and not to 1. Moving on to a voltimeter, again it should be to 2 decimal places. For instance, in the lower scale where we've the scale for 3, that is 1.7. So we should fill with a 0 to act as the placeholder, since all measurements should be taken to at least 1 decimal place, but high accuracy is not penalized. So 1.7 or 1.70 would work, but this is 1.7 voltage. A milliammeter measures least current or a very small amount of current. Again, its reading should be to 2 decimal places. Then moving on, we look at a galvanometer, a center zero galvanometer. We use at least 1 decimal place, but majorly or mainly we are required to make sure that the galvanometer balances at 0. We have the negative and the positive terminal. Then we have the beam, electric and spring balance. We just put the item you are measuring on the beam balance, and then the reading is taken in grams. Spring balance we hang, and electric balance also we do the same. That one we read it directly the way it appears. Now, how do we make a connection? I have an example of a connection there. How we do a connection from the negative terminal of the dry cell to the negative terminal of the ammeter. Then from the positive terminal of the ammeter comes to the resistor, then gets to the opposite terminal, which is, and I have a case example of a connection. The connection should be arranged just the way it appears on the question paper, like in my case. So the red knobs represents, so this is for example my diagram showing how we would make the connection. The circuit symbols for the bulb, ammeter, voltmeter, the cells, and so on and so forth. And then the connection is right there. So from the positive terminal of the cell, or from the negative terminal of the cell, you can see it gets to the voltmeter at the same point, which is the negative terminal, the black one, then to the switch, then to the ammeter. It goes to the negative, leaves at positive, to the bulb, gets to from the negative terminal of the cell, heads to the negative terminal of the voltmeter. Then again it goes to the switch. From the switch it will get to the negative terminal of the ammeter. So from negative to the negative, then leaves at positive to the bulb. Then from the bulb it will come to the potentiometer. From the potentiometer gets to the positive terminal of the cell and gets to the positive terminal of the voltmeter. You can see the voltmeter is already reading 3 volts. That is the reading of the voltmeter before the switch is put on. So when we put the switch on, the voltmeter reading drops, as you can see. So it drops to around 3. We're using the upper scale or the lower, and the ammeter reading, you can see the 0.08 there, and you can see the bulb lights. So that is the current that is flowing in the bulb. that is recorded. So if you try to vary the current, the bulb goes off. When I minimize the current, if I increase the current, the voltmeter, the ammeter reading increases as well, because it means the amount of current flowing also increases, because I'm varying the amount of current in the circuit, and the bulb lights brighter. So the voltmeter, we are using the upper scale. So when the current is high, the voltage drops. And these are just a simple connection. I'll be making several videos on how we conduct physics practicals. If you are yet to subscribe to my channel, kindly subscribe so that we learn together. So those are the just basic things that we do in physics paper 3. Simple connection. We have the wires. You can see the deflection of the voltmeter and the ammeter. But the introduction to the apparatus we use in the laboratory. This is the switch, the one I'm holding. You can see the bulb lights when I complete the circuit. We call that a closed circuit. And when the switch is off, that is a closed